Hello everybody, how are you? Welcome to Ask Math Anything. And we're happy to be able to have this opportunity to welcome possibly some new people, as well as welcome back some old people, as what we do is we try to answer some math questions that people have. It sounds like people who like to join this live stream typically have lots of random questions about mathematics. Oftentimes they happen to be about bananas or broken calculators. But what you'll find out is that they actually generally tend to be about algebra or geometry, because what we try to do is we try to explain how you can use the ideas from algebra and geometry to understand a lot of things. As was mentioned in the announcement, unfortunately this live stream won't be able to run every day this week because of a couple of things going on. I unfortunately tomorrow have an event with the US Math Olympiad training program, because I guess I'm the coach. And on Thursday, there's another special event that I need to be involved in where Carnegie Mellon University is talking about the efforts that Carnegie Mellon researchers are taking to try to stop the spread of COVID-19. So I'll be away for both Tuesday and Thursday, but we'll be here still Monday, Wednesday, and Friday. All right. Well, let's go ahead and start. It looks like I have chosen to wear a banana-colored shirt today, which apparently has inspired people to ask questions about what's the best way to plant bananas. Unfortunately, this is not Ask Bananas Anything. It's Ask Math Anything. And I don't know the answer. I would guess if I wanted to plant bananas, I would probably attempt to take a banana and put it in the ground and see what happens. Okay, let's try. More questions. What can we have here? I see a question by Danny Lam. It looks like a probability question. And this is a question I'm not going to do, but I'll explain to you why. Danny Lam says, there is a game. A guy draws 10 cards. There are 21 cards. And those 21 cards come in 3 distinct cards, 1, 2, and 3, each of which has an equal chance of being drawn. Find the chance that some other guy gets the sum of the cards drawn. The reason I won't do this one exactly is because these kinds of questions are ones for which usually the only way to get the real answer is to do a lot of cases. Because unfortunately, there's not a nice formula for the answer to the question you asked. And because the numbers were fairly big, like 21 cards, the kinds of things you need to add are a lot of them. So the way to think about math is that, all the formulas you learn in school, those are the times when there's a nice shortcut and it's just amazing and you can solve things very nicely. But then, unfortunately, there are a lot of problems in math also where the only answer is, well, just count all of them, or just try to do all of them. And then when you do that, you'll get an answer, but it's best answered by a computer as opposed to a person, or a calculator as opposed to a person. Oh, let me say something about calculators. Since many people here seem to like calculators, I want to share that if you're lucky enough to be using a graphing calculator, a programmable graphing calculator, like one of those TI graphing calculators, you actually can often write programs to solve your problems. And so it's not a bad thing if you're doing math contests that allow calculators to learn how to program your calculator. Because sometimes, if you find out that all you need to do is to go and analyze these 1,000 different things, if you can write a program for your calculator in 5 minutes, then you can have it do the 1,000 things. I've actually used these kinds of methods before when I was doing math contests. Oh yes, you can totally write programs on the TI graphing calculators. You just have to learn how to do it. It used to use a language called TI Basic. And in fact, very, very early on, as soon as I got my first graphing calculator, I taught myself how to program in it. So that if I ever had a brute force problem I had to do on a math contest, I could just program out that calculator and make the calculator do it for me. That's a random trick. All right. Oh, somebody said that's cheating. I'm not sure that's cheating. If the contest allows you to use that particular calculator and you wrote that program during the contest, how is that cheating? That's just using your tool in the way that you can use your tool. All right. More questions. Xiao Zhu Cheng has asked a question about bases. And what you said is if you take the number 9 in base x plus the number 10 in base y, then that's equal to 21. No, sorry. 9 in base x plus 10 in base x is equal to 21 in base y. And the question asks, what is x plus y? But I think that's usually because the question is asking for a number. Let's just go and figure out what are the possible x's and y's. That's what we're going to do. If you see something like this, what do? You first try to write it in a way that looks more like algebra. You try to write it in a way that looks like an equation, right? Like, who writes x down here? You think about what the place value means, right? Oh yeah, somebody said, look, 9 plus 10 equals 21. Not every day. But if you think about place values, the 9 with just an x there, that's a 9. What's the 10 with an x there? That's just x. Remember, because this is 0 in the 1's place and 1 in the x's place, so that's x. That's equal to 21 in base y. What does that mean? Well, 21 in base y means 2 y's plus 1. Okay, let's go solve this equation. 8 plus x equals 2y. It looks like there are tons of solutions. You see, because I could just go and choose any y that I want, which is at least, not really. I need to be careful. Nobody can write 9 in base x if x was 3. Remember, the digits you're allowed to write in your base have to be from 0 up to the base minus 1. So I need to have that x is at least 10. Okay, so x is at least 10. Since x is at least 10, that's the same thing as having y be at least 9. And the reason is because 10 plus 8 is 18. 18 is 2 times 9. So now I know that y is at least 9. Now what I'll say is, actually any number which is at least 9 for y is going to work. Because what I could do is I could go and say, let's let y be 9. Then this is 18, and I say then x is 10. In fact, there's a way to figure out what x is. X is always equal to 2y minus 8. So I have lots of choices. I could make y be 9, and then I get 10. I could let y be 10, and then I get 12, right? 20 minus 8 is 12. Or I could let y be 11, and if I do 11, it's 22 minus 8, which is something that is hard to figure out. 14, right? But it just keeps going. There's no limit, because your base could be as big as you want, as long as it's an integer, a positive integer. So there's lots and lots and lots of answers. There's not just one answer. There's not just 2 answers. There are not just 100 answers. There are infinitely many answers. Wait, is that actually right? That's really interesting. I'm starting to doubt myself. That doesn't feel, maybe it's okay. Yeah, it's actually okay. No, this is totally legit. This is fine. I was a little bit worried because I was like, hang on. 9 plus 10, that's pretty small. That's 19. How could 19 equal to 21 when I convert between 2 bases? Oh, but it can, because I just need that one of the bases is big, and the other one is also very big. All right, well, that was fun. So I guess that this answer has many solutions. Thank you very much for asking it. More questions. This is interesting. Let's go and find out what the answer is here. I'm trying to figure out if this is a legit question or a troll problem. When I say troll problem, it's like if the only way to do it is brute force, then we won't do it. But Ellen Wei has asked, there is a number which has 94 nines. So it's got a lot of nines. 94 of these nines. And what you want to do is you want to multiply it by a number which has 95 sevens. Ooh. Now, that's a lot. That's really big. But the question says, what is the sum of the digits? Wow. Who wants to do this by just multiplying? Let's go and multiply. Let's write a big thing and multiply. Anyone want to join me? No, it would be terrible. But actually, there might be a way to do it. See all these 9s? I like multiplying numbers by lots of 9s. Because if I see lots of 9s, it's really close to 1 with lots of zeros. Let's go and rewrite this number. It might still be a troll problem, okay? But I have some hope. I will go and say that the 9999999, that is 10 to the power 94, almost, minus 1, times 95 sevens. Okay? And this is because this is just 1 with 94 zeros, right? If I just took all these 9s and I add 1, I should have 1 with 94 zeros. Now, why is this something we might be able to do? Is it or is it not? Let's find out. If I wanted to write this down, what is this? Well, the first one is 95 sevens times, a 1 with 94 zeros. So it should be 7, 7, 7, 7, lots of sevens, 95 of them, followed by a lot of zeros. How many zeros? 94 of them, minus 95 sevens. How many people are okay with what I just wrote down here? What I just wrote down here just says that I have my number which had 95 sevens and it has 94 zeros after it, which is okay. And what I did here is I said, oh, you see, there's going to be a 7 over there. And the reason there's going to be a 7 over there is because there's 94 zeros and there are 95 sevens. This is something I can actually do. If I want to go and subtract now, so 10 minus 7 is 3. But the next one becomes 9 minus 7, so that's 2. And there's a bunch of 2s all the way to here. These are all 2s because the last 9 minus 7, because I borrowed from there, 9 minus 7 is 2. But then I borrowed from that one, so that's a 6. 16 minus 7 is 9. Okay, I think. Is that right? 16 minus 7? That's 9, okay? The next one over is going to be, since I borrowed, it's a 6. But can anyone tell me what the rest of these digits are all going to be? Actually, this is not a troll problem. We're going to get it. We're going to get this problem. So what's the rest of these? Sevens. Sevens, of course, because I just have sevens. I didn't do any more borrowing. So just a whole bunch of sevens. Okay, the problem asked, what's the sum of the digit? What's the sum of the digits? So now let's just go and start adding. So first of all, how many sevens are here? Can someone tell me exactly how many sevens should be there? Not 95 anymore. 95 was all those sevens. This is 93, right? Because remember, that last 7 became a 9, the next one became a 6, and then there's 93 of these. Next, there will be a 6, and there will be a 9. Now, how many 2s are there? Who can figure out how many 2s there are? I guess it's useful to look at what's on top. There were 94 zeros, so the number of 2s is 93 2s. Hey, actually, you know what? We didn't just figure out what's the digit. We didn't even just figure out a way to get the digit sum. We even said what the answer was. Hey, you know, when we looked at this, how many of you actually thought this would be a troll problem where the answer is just blah? I did. When I saw this on the moderator chat, I said, are you really going to ask me to do a completely horrible multiplication and get like 37210096 blah 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 blah? I thought it was going to be a big mess, okay? I thought it was going to be a big mess. And I thought we were going to need to use a fancy trick in order to figure out just the sum of the digits. Some of you I see weren't fooled. Good for you. I was fooled. But I put it anyway because I was like, I'm curious. Oh no, did I do it wrong? Is it 2-4 at the end? Let's see. Here's how I would check. First, I would say, maybe my fancy calculation is wrong. Let me go all the way back up and say if I multiplied the old-fashioned way, 9 times 7 is 63. So I do expect a 3 at the end. So I don't think we made a mistake on the 3. But the answer is not bad. It's like we can just add this up. Yeah, I see that some people said, like Harry Liu said, I'm not scared of that because all those 9s. Good for you. Okay, let's get the answer. 93 times 7. 93 times 7. Whoa! Hey! It's not 93 times 7. It's 93 times 7 plus 93 times 2. That's 93 times 9. I like to do that. 93 times 9 is easy. That's 93 times 10, 930, minus 93. 93 is actually 100 minus 7. So if I was doing that in my head, I would say 837 because I would drop 930 to 830 and add 7. Or you can do it slowly. Oh. Slowly is really hard. How do you do this slowly? Ah, yeah, okay. Actually, slowly I'm more likely to make a mistake. But anyway, so this is the two blue brackets. That adds up to 837. And I also have a 6, 9, and 3. Oh, that's nice. 6 and 3 is 9. And plus another 9 is 18. So I want to take all of this and add 18. Okay. Part of me is saying, then I should just have taken 95 times 9. That's what I should have done. Let's take this back. Because if I have 93 times 9, plus another 9, which is 6 plus 3, plus another 9, which is just a 9, actually my answer is just plain 95 times 9, which if I use the same trick I was just doing, this is 950 minus 95. 95 is 100 minus 5, so I can do this by taking 950 and dropping to 850 and moving back up by 5 to get 855. And that matches what I saw some people putting in the chat. So that was the answer. Not bad. Thanks very much for sharing this question. I didn't expect it to be this nice. More questions. Sunwatcher234 has asked, in how many ways can you arrange 16 bananas, 17 broken calculators, and 18 Po-Shen Lohs? Now, this is an interesting question. If I wanted to interpret it as you want to put them all in a line, that happens to have, an answer. But if you just said how many ways can you arrange it, the answer is infinitely many ways. Because, if you are allowed to scatter them any way that you want, you could put a banana over here, and I guess one of me is here. How do you get two of me? That I don't exactly know, although I do know that right now there seem to be like 3 of me in this room because there's me here, and then there's me in that screen over there, and me in that screen over there. So at least I know what it might look like to have 3 of me in the same room. On the other hand, I don't think that's what you asked. I'm just going to say, let's talk about how many ways there are to rearrange if I wanted just a line, okay? And if you wanted to have just a line where you had 16 bananas, which we'll call B, 16 bananas, 17 broken calculators, and 18 Po-Shen Lohs. If you want to know how many ways can you rearrange these in a line, well, then all you have to do is you have to say, I guess I should try to rearrange altogether the 51 things. If you want to add these 3 numbers, the easiest way to add 16, 17, and 18 is to take the average of them, which is 17 times 3. 17 times 3 is 51. So, there's 51 things. The number of ways I can rearrange 51 things is 51 factorial. But that's not quite the answer. Because if I take any arrangement, the bananas are indistinguishable. They're all bananas. And as we've talked about on this live stream before, all bananas are actually clones. This is a very interesting fact that the bananas you're buying at the grocery store, the reason they all look the same is because they're genetically clones, right? So this is actually a pretty good example. Since the bananas are indistinguishable, you divide by 16 factorial, the number of ways you can rearrange the bananas. Next, calculators. As everyone knows, calculators they may as well be clones too. Calculators are all from the same brand, they're all the same. So the ways to rearrange these 17 identical TI graphing calculators is 17 factorial. And apparently you guys told me you found a way to clone me. So since they're all indistinguishable, you divide by the number of ways that you can rearrange the 18 Po-Shen Lohs, and that happens to be the formula. All right. Oh, Elaine Joe says, what? I didn't know that bananas were clones. Then you've learned something new in today's live stream. So unfortunately, all the bananas in the world are clones of the same thing. That's why they look the same, Not quite all the bananas. If you go to some stores in some Asian countries or in the Mexican supermarkets, you can see other kinds of bananas. But the majority of bananas are the same. All right. More questions. Ah, Codecrafts has asked, do you know any math competition that allows TI calculators? TI graphing calculators, I assume. Honestly, I don't follow all the details of math competitions anymore, so now I don't know. But I do know that a long time ago, like when I was doing math contests, I think that on the AMC12, you actually got to use calculators. I vaguely seem to remember this. Or at least there was some other one. Oh, math counts! Oh, come on, of course there's one. Math counts. You can totally use a calculator in math counts, and it can be a TI graphing calculator. You know why? Because actually, if you ever make it to national math counts, and you're one of the members of a state team, you get a prize. And the prize is from one of the sponsors of math counts, which is Texas Instruments. So actually, everyone who goes to math counts nationals usually goes back with a new TI graphing calculator. And therefore, it makes sense that you can use the TI graphing calculators in math counts. Or else, it'd be kind of weird to say, congratulations on winning this contest where you weren't allowed to use calculators. Let's give you a calculator. Okay. More questions. Oh yes, somebody did say, Spaced Out said, QWERTY calculators aren't allowed. Wow, what's a QWERTY calculator? I've never heard of a QWERTY calculator. I've only heard of a TI graphing calculator. What's a QWERTY calculator? Well, a QWERTY calculator just means that it happens to have a keyboard that has QWERTY as the letters on the keyboard. For whatever reason, the rule became calculators that have QWERTY are not permitted. Because I guess that was an easy way of making computers not allowed back in the day. Actually, that's how this was. It was this way even long ago. But in case anyone wants to know a piece of very interesting TI graphing calculator history, I don't know if you guys have ever seen this one before. I don't know if you've ever seen this one before, but has anyone ever seen this? This is a super cool calculator. Has anyone ever seen a TI-92? I'm actually not sure if you guys even know that there is such a thing as a TI-92. Yeah, TI-92. You've never heard of this thing? It's amazing. The TI-92 is actually what was the new calculator in the year that I went to math counts. My final year at math counts was 1996 or something like that. And they gave everyone a TI-92. And if you go Google for TI-92, it's a beast. It's a calculator that looks like a rectangle the wrong way, you know? Not like the long skinny rectangle. It's like a big old, like this kind of rectangle. It's amazing. Yes, people said they searched it up. It looks weird. It sure looks weird. I mean, it's pretty thick. It's like a thing that you hold with two hands. And the TI-92, it looks like this. I think it was something like this, right? And then there was even like some circle bar. I think that there was something like this too. I don't really remember. It's been ancient since I ever saw this thing. But it's got something which you can use it like a direction pad. It looks like a flip phone. I love how you guys say it looks like a flip phone. You know, this thing was released to the world before flip phones were invented. Right? This is like, you're probably wondering, why would anyone buy something like this when they could just use a computer? Well, it's because it was 1996. And so, it's not like everyone had laptops walking around. Laptops weren't really a thing that everyone had walking around. And definitely nobody had flip phones. So this thing was amazing. And in fact, I'll tell you, when I was doing like math stuff in high school, this was so much fun to use because you could actually go and type on it, sort of like a computer to go and type stuff. Anyway, whatever. So now you've learned some ancient piece of history, but that's why these calculators were not allowed on contests. This is TI-92. It had like a real legit keyboard down here. All right, so now let's do some more math. What's this? Daksh Gupta is giving us a sequence. I think we'll take a break from broken calculators for a while since I just told you about an amazing calculator which people don't know about anymore. But here's a sequence. Daksh Gupta wants us to figure out what's the next number in the sequence of numbers. And I have no idea. Let's find out. Where'd that sequence go? Looks like my moderator team just erased the sequence. So in that case, maybe we'll not do that question right away. Either that or I can't read and the sequence vanished some other way. Or Daksh Gupta, maybe you can put your sequence back in. Oh no, I made a mistake in the last question. Wait a second. Somebody told me I made a mistake in the last question. Did I? I could have. Somebody said 10 to the power 95 minus 1. Is it? I think it's okay. I think it's okay. It's not 10 to the 95 minus 1 because 1 with 94 zeros is 10 to the 94. Okay, we're okay. We're okay. But thank you very much for raising these things because I do make mistakes. Everyone who watches this live stream knows I make tons of mistakes. So I do need you guys to help me out. Okay. More questions. And now we have Daksh Gupta's sequence. Okay, Daksh Gupta's sequence. 3, 2, 5. Nice number. 2, 6, 3. 6, 4, 2. What? Got smaller and then bigger? What kind of a weird sequence is this? 4, 3, 6. 3, 7, 4. 7, 5, 3. 5, 4, 7. You're going smaller and bigger and smaller and bigger. 4, 8, 5. Whoa. All right. What can we do? Oh, I see some stuff going on. I see a 2, 5 and I see a 2, 6. I see a 6, 3 and I see a 6, 4. I see a 4, 2 and I see a 4, 3. 3, 6, 3, 7. I get it. So if it's 8, 5, it better be 8, 6. But what's the deal? How do you get that 3? So it was 325 and then 263 and then 642. What's going on? How are you getting a 3 out of a 2, 6? This is sort of like a broken calculator. But it looks like we need to find some kind of pattern. It's like somehow when I have 3, 2, it got to 5, 2, 6, it went down to 3. Sometimes it's small, sometimes it's big. And, like that's 5, 4, 7. Huh. What is this? A lot of people seem to think the answer is 4. You guys are really fast. Very good. I'm not that fast. What's going on here? So 3, 2, 5, that adds up to 10. 2, 6, 3 adds up to 11. Oh, it adds up to 12. Adds up to 13. Adds up to 14. Adds up to 15. Adds up to 16. Adds up to 17. It needs to add up to 18. Aha. It needs to add up to 18. And the way you add up to 18 is 8, 6, 4. Nice. Thanks for that nice question. That was a very interesting problem. Thank you very much for sharing it. Of course, sort of makes me wonder what would happen if I kept going. I could go one more. Add to 19. 19. And then it has to add to 20. I can still add to 20. Then it has to add to 21. This is hard. 16 plus 5 is 21. Then it has to add to 22. 7 and 6 is 13. 13 plus 9 is 22. Right? And then you get weird stuff happening. Right? So it's like, what do you do? So I guess I'm just saying, like, this is kind of a neat sequence. Okay, I'll tell you what I thought would happen. I thought I was going to tell a joke and have it break right away. But it turns out it didn't break right away. It just keeps going. Of course, the question here is now what do you do next? Does it go to 7, 0? If it does, then we are in trouble. But then, what do we do? Not clear. In any case, it's an interesting question. Yeah, is it 707? I guess we could try to think about what you do, maybe mod 10 or something, but then it becomes a little harder. So let's not continue with this one, but thanks for sharing the problem. Okay. First digit of first number plus last digit of second number. What does that mean? First digit of first number plus last digit of second number. Oh, what? We're thinking way too hard. Wait, that's neat. Oh my gosh. Okay, so we just found like 2 ways to do this. First of all, somebody told me you don't need to do this stupid thing where you add all the digits. That was like, we were thinking way too hard. You just go and look and you're like, hey, check it out. Same digit. Just copy it. Oh, Okay, in that case you can just do this forever, it will work. And the interesting thing is, like, it works for this thing that I just said, because since we go from here to that thing plus 1, since we do that, that's why you get a plus 1. That's why it's like adds to what? Adds to 10, adds to 11, adds to 12. And it still works for a while. And then at the end, it's like, oh no, that's when I got stuck. But actually, if you use this method of just copy the digit, then there's no trouble. It works perfectly. Thanks for sharing that. And it's really interesting to see how you can sometimes have two different ways of looking at the same thing, and they're the same. Okay. More questions. P14Y3R0N3 asks, when you wrote your name in school, you wrote the hyphen, right? Yes, I did. I wrote the hyphen. Actually, when I wrote my name in school, I wrote the whole name, Po-Shen Loh. That's because I have a brother, Po-Ru Loh, and a sister, Po-Ling Loh. So I actually don't just go by Po everywhere, well, when my family's around, because there's 3 of them. So that's why there's a hyphen in between. Okay, more questions. Ooh. Abhishek Bhattacharjee. Yes, Abhishek Bhattacharjee asked, how many ways can a person go from 0, 0 to MM without touching the diagonal? So, you know, like, just stay below the diagonal. That's a famous problem. It's actually called the Catalan numbers. And I won't go into that on this live stream, because there's actually 2 YouTube videos that run for like 2 hours total, where I go and actually explain all of that in detail. Just search on YouTube for Po-Shen Loh Catalan numbers if you're curious. And you can find there's a really complicated way to do it first, which I show to high school students. And then at the very, very end of the second video, maybe in the last like 15 minutes, I show, hey, by the way, you can do it really easily. So you might want to jump all the way to there. Yes, Min Ko, that's right. It's in the NYMC, New York Math Circle. And so I actually used to always go to the New York Math Circle to go and give these math talks, maybe about once a year. And one particular year, I did a talk about Catalan numbers, and they recorded it, so it's all there. 5 years ago? Is that true? I lost track of time. At this point, I sort of only really know what's going on like 5 hours ago because of all the different work that we're doing. But apparently that was 5 years ago. Neat. Whoa, Minko says you go to New York Math Circle. That's great. What that means is that sometime in the future, I'll give a talk there again. When the world returns to normal, I'll go by and visit New York City Math Circle again, probably in like a year or 2. Maybe I'll see you there. Okay, more questions. What is this? Jeffrey Liu. What's the biggest number you know besides infinity? You want something to be bigger than infinity. Well, the issue is that somehow infinity is not really a number anyway, because you can't really do math with it. The reason we say infinity is not a number is because it's very hard to say, hey, check it out. Do you know what should be infinity plus infinity? Well, actually, that one's okay. If I wanted to have a reasonable sense of what's infinitely big plus infinitely big, I guess I may as well say it's still infinitely big. That might be reasonable. But something that's not good is if I try to take infinity and, you know, let's go and add 1. Well, that seems reasonable. Oh, wait, you know what? I don't even need that. I don't even need that. Hey, this is why infinity is not a number. Now, all I'm going to do to this equation is I'm just going to subtract infinity from both sides. So I just take this and you subtract infinity from both sides. Subtract only one infinity from each side. Right? That's easy. What do you get? It seems reasonable. Subtract one of the infinities, and you get infinity equals 0. Don't try this at home. This is not okay. Not okay. You're not allowed to do this. The reason you're not allowed to do this is because infinity is not a number. And that's the reason why infinity is not a number. It doesn't satisfy all of the rules you expect numbers to satisfy. For example, it would just be awful if people said, you know, when you do algebra is okay. But if you ever get the number 73, you're not allowed to subtract 73 from both sides. Like, what would that be like, right? Imagine that you had to do all of algebra, except that whenever you got the number 73, it was just bad. 73, not allowed, and you just can't do things with the 73. All of your algebra would go nuts. You'd have been like, oh yeah, I analyzed the problem, but in the case when x equals 73, then that thing. So that's why I'm just explaining what kind of a nightmare it would be if when you do mathematics, there's like weird numbers that you're not allowed to use. That's why what we make our number system to be is numbers for which you can do everything. Is 73 my favorite number? No, I just thought of it like right now because I was like, let me think of a really wacko number. And I thought 73 seems reasonable. But infinity now is one of these things where, you can't do this stuff to both sides. You can't subtract infinity from both sides. That's why people don't say that infinity is a number. So if you ask me what's the biggest number I know besides the infinity, I would say, actually, I don't know about infinity. I don't know if that's a number. So if you want me to say the biggest number that I know, gee, that's hard. How would I go and say a number? Oh yeah, here's a fun thing. Does anyone know? Let's try this. You get 9 nines. Write the biggest number you can. All right, who wants to try? You get 9 nines. You can do anything you want with those 9 nines, except no factorials, okay? That's just like, that's cheating. Okay, no factorials. That's the only one I'll say. No factorials. Okay. What about powers? Yes, you can use powers. So I can use powers. So some people said, so we got some things here. People want to use powers. And somebody said, add the word TREE in front, like a tree. There's something pretty good you can do. This. This is pretty insane. So if you go and do this, you have something bigger than what you could imagine. Because if you just imagine how you expand this, you start with the top, 9 to the 9. That's already pretty big, okay? So this piece, 9 to the 9, that's already a legit serious number. That's like seriously big. But then you have to take 9 to it. And then it's like, oh no. Somebody said the calculator broke down on the third try. Looks like we have a way to break calculators now. Please do not break your calculator. But if you do 9 to the 9 to the 9, it's it's pretty decent. But if you do 4 of them, like 9 to the 9 to the 9 to the 9, oh no. And then all of these, 9 of them, it's terrible. So actually this is pretty serious. And so if you ask, like, how do you write a big number? If I'm only allowed to like write the numbers down and move them around, I would use this. If I was able to do some other things, I could also potentially make big numbers by repeating these steps. So if I was able to write dot dot dots, there's another way you could do it. 9 to the 9, dot 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 9. I've only used 3 9s so far. 9 to the 9, dot 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 9. That's 3 more 9s. 9 to the 9, dot, I can't do any more dots. 9 to the 9 to the 9. Yes, wait, no, that's cheating. I agree with you. This is cheating. But I think this is the answer if I'm only allowed to write the digits. The dot 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 is totally cheating, especially because I got to write this like curly brace as well. But I just simply wanted to share. By the way, do you know how big this is? This is serious. This is like, oh no. That's what this is. This is oh no. What are those curly braces? What does it mean? If I write this curly brace, it means the number of 9s in this is just that many of them. Right? It's like curly brace means how many 9s in this tower? That many. Not a serious number, just that many. And then now, what is this? How many 9s are in here? Oh, just like that many. That's cheating. I agree. This is totally cheating. Don't try this. Not allowed. Cheating. But this one is not cheating. Which is pretty good. Okay. Let's see. What can we do next? More questions. Okay. So I see that there's a few things I'm going to take as some quick questions, right? So Maz Ahmad asked, can I have your contact for personal math assistance? Very curious, but lacking help. Here's what I'd say. I myself am just trying to get people interested in math. I'm glad that you're watching this stream. But if you want to get help from other people, there are actually places online where people often ask questions. But if you're a professional mathematician, a lot of people ask on Math Overflow. People also ask on Quora, and then there are all sorts of other websites where people also pose questions, like Art of Problem Solving's forums. So basically, I would say if you write these, if you have these questions, the best is to ask other people. My main role, what I try to do is I try to make it fun and try to get people interested. I actually spend relatively little of my time helping individual people learn their mathematics, because I like to try to reach as many people as I can. Oh, what is this? I'm trying to see what this question means. Oh, this is interesting. Do we have any chance of doing this question? I think, yeah, let's try this, okay? I'm not sure where this is going to go. This could be a disaster. Let's see. It's a question that has absolute values inside it. So this is by Rishabh Stark. And Rishabh Stark says, I have absolute value of x minus 1 multiplied by absolute value of 2x minus 4 equals 5. The question asks for the range of x, but I'm just going to say, let's find out all the x's that work. Now, I'm happy. This is not going to be a disaster. No need to take shelter. This is okay. I just chose this because, by the way, you can tell, I choose questions when I'm like, gee, I wonder what that answer is. That question looks kind of weird, and it could be a disaster, but that's what's going to make it fun. And maybe we'll have to do casework, right? I saw this and I said, it's about time we talked about absolute values in this live stream, and that always has casework. But in this case, I don't have 4 equations. This is a nice version. If I have absolute value of something times absolute value of something equals 5, I'm going to use a trick. The absolute value of x minus 1 times the absolute value of 2x minus 4 is actually exactly the same as the absolute value of x minus 1 times 2x minus 4. That's a very powerful first observation. It's going to cut down our casework by half. You see, because if I take absolute values first and then multiply, it's the same as multiplying first and then taking the absolute value, right? Are people okay with this? It's like absolute value just means drop the minus sign. So, if I had minus 4 times 6 and I absolute value each of them and then multiply, I might as well just multiply them first and then absolute value and then just drop the minus sign. Nice! So now I get to save work. Look, if I want to know when is this absolute value equal to 5, then it's going to be either that the thing inside is 5 or the thing inside is minus 5. Okay, so I've got 2 problems. I only have 2 cases to deal with. I've got one case, which is x minus 1, 2x minus 4 is equal to 5. And I've got another problem to do. The other problem is going to be x minus 1, 2x minus 4 is equal to minus 5. So I just need to do 2 problems. Let's go. Now, how do we expand this? It's like multiplying binomials. That's what somebody said. So you multiply the first things first. So that's 2x squared. Then you have minus 4x. Okay, let's see. So it's got to be a minus 4x and minus 2 more x's. So that's minus 6x. And then plus 4 equals 5. Okay, now let's go and put that together. And I get, what is this? It's quadratics time, right? Hopefully I didn't make a mistake, because I always do. This is 2x squared minus 6x minus 1 equals 0. I look at this and I immediately say, this is not going to be factorable. The reason I know this is not going to be factorable is because if I try to factor the 1, it's like 1 and 1 with some minus signs. Factoring the 2 is like 1 and 2 with some minus signs. There's just no way that you can put this together to get a minus 6. So we go and use this famous formula here, and we can find out what happens. So then here, x is equal to negative of the middle term, that's just the plus 6, plus or minus the square root of middle term squared, 36, minus 4 times the 2 times the negative 1, that's a plus 8. All over 2 times 2, which is 4. Okay, we'll get some answer. Some people said, do it your way, please. In this case, like even though I came up with some simple way to try to think about quadratic equations, that doesn't mean that's the only way I ever want to use. It's nice to always use different techniques based on what works the best for the problem you're doing. And so let's do this one. That's 6 plus or minus 36 plus 8, 44. 44 will give me 2 square root of 11. Because 44 is 4 times 11. Okay, and so what I get is 3 plus or minus the square root of 11 all over 2. Now those are some of the answers. Let's finish it up on the other side. I already now know what's going to happen. I'm going to get the same thing on the left, 2x squared minus, let's skip a step, minus 6x, and it will become what? Plus 9 equals 0. All I did here is I said if this was a minus 5 and I add 5 to both sides, I get 9. Can I do factoring on this? Also doesn't look fun because the 9 will become like, yeah, it doesn't work. 9 becomes 3 and 3, and you cannot put that together with the 2 and the 1. All right, here we go again. This becomes x equals 6 plus or minus the square root of 36 minus, what's this? 4 times 2 is 8. 8 times 9 is 72. Oh boy. It's going to be fun imaginary number time. So that's equal to 6 plus or minus square root of minus 36. Uh-oh. Square root of minus, somebody said, how can it be minus 5? How can it be minus 5? The way it can be minus 5 is if the inside is minus 5, the absolute value of minus 5 is still 5. So if I ever have absolute value equals something, then I can have the inside is either that something or minus that something. Okay, and we get 6i all over 4. Okay, that's equal to 3 plus or minus 3i all over 2. And these are all the solutions. These are all the solutions. It's one or the other. So that was nice. This was actually not so bad. Originally, when I looked at this, I thought, are we going to have to do some weird inequalities? Are we going to have 4 cases because I have 2 absolute values? No, there's a trick. And the trick is just to go and save yourself half of the work. Cool. More questions. I'm looking at this to try to find another reasonable good math question that we can hit. And oh yes, you said haha, they must be the same because of the equal sign. No. Let's not put that there. Okay. Now there's no equal sign there. So now you're just like, hey, how did this happen? Well, it's purple, so it's got to be like the purple things. Okay. More questions. I see that PCK-TSP has asked, how do you prove Pythagoras' theorem? The good news is that there's actually a complete proof of this, my way of explaining the proof, on the Daily Challenge website. So if you just go to the Daily Challenge website, that's daily.poshenloh.com, there's something in there which has a completely free thing that explains Pythagorean theorem proof. Then that would be my explanation of this. More questions. Oh, that's neat. Moonwatcher123 has said a calculator can display 10 digits. Okay, this is actually a kind of question that I often thought about when I was young also. So a calculator keypad usually looks something like this. Sort of. Okay. Actually, I forgot what a calculator keypad looks like. It's 7, 8, 9 up here, right? And then there's 4, 5, 6. And there's 1, 2, 3. And I ran out of space. Where does 0 go? Does anyone remember where 0 goes? Is 0 here? I actually forgot. I don't use calculators anymore. I don't know whether 0 is here or whether 0 is in the middle. It might actually depend on the calculator. Under the 2. Okay, thanks. So it's just like a telephone. Okay. And now the question here is, if you have a calculator, and if you have something moving like a knight, which is jumping around this calculator like a knight, the question was, how many ways can I make a number where I jump like a knight in chess around this keypad, and I need to hit every single one of these numbers exactly once? The first part of me is like, is that even possible? That's cool. Is that even possible? I see that some people's calculators is under the 1. I see some people agree with my under the 1. Some people think it's under the 2. It's okay. Both of these are questions. I'm actually just curious what the answer is. Let's do it for here first. You play chess and it works. So it's actually possible? I didn't even know it was possible. Let me try. If I want to go and do it like a chess, well, I guess I should write the number. Oh, let's try. 0, and then 4, and then 9, and then 2, and then 7, and then 6. Oh, wow. What I'm seeing is that there are some things that are forced. 7, and then 6, and then after 6, I guess I have to go to 1. This is really neat. And then there's an 8, and there's a 3. Oh my gosh. Where's 5? Wait a second. Now I'm terribly confused. How are you going to get to 5? It's like, excuse me, there's a 5 here. So I think that if you put a 0 down here, the answer is impossible. Because I was like, check it out. As I'm doing this, I'm basically finding myself going into here and having no choice, right? Maybe I had a choice of 0, but I started with 0. And then at some point, it's like the 3, if I go into the 3, I go out that way, right? So like whenever you go into the corners, you basically just have to go in and out that way. That's kind of neat. Except the 5. Ouch! Nobody loves the 5. So let's go and actually say we probably have to play with a calculator where there's a 0 here. But because of that, actually maybe this question has a systematic answer. Since the 0 is there, that now tells me what I need to do with the 0 to get to the 5. In fact, let's observe. You have to either start at the 5 or end at the 5. Does everyone agree? Because from the 5 only can go to 0. There's nothing else. You either start from 5 or you end at 5. So let's just start at 5, see if anything happens. And if anything happens, well, that's going to be the answer, and then we can flip it. Actually, I think we can do this problem. This is a really nice problem. Thank you so much for sharing it. I did not expect it to be nice. Start with the 5. Now from the 5, no choice. You go to the 0. When you go to the 0, there's no choice. It's the 3. Now I have choice. Ooh, I have choice. Oh, interesting. So here's how we're going to do it. It goes 5, 0, 3. And now we've got some choice. Either the 3 goes to the 4 direction or it goes to the 8 direction. But I bet that each of those is legit. So I'm going to do this. It's like a tree diagram. If I go to the 4 direction, now from the 4, I have no choice. Because 3, 4, I have to go to 9. Okay? If I went from the 4 to the 9, I have no choice but to come down to the 2. From the 2, I have no choice but to go up to the 7. Okay, this is a nice question. From the 7, I have no choice but to go to the 6. From the 6, again, no choice but to go to the 1. No choice because the 6 is only connected to the 7 and the 1 by jumps. The 1 has no choice but to go to the 8. And then we're done, right? Are we? Let's see. That's 7 digits and 3 digits. That's 10 digits. That's nice. And you know what happens if you go from the 3 and instead you go to the 8? You basically flip this thing around. Okay? So the other way is that you go 8, 1, 6, 7, 2, 9, 4. Is that okay? These two just reverse. This is cool. And the reason is because it's almost like train tracks. It's like there's a very clear train track. You go into the, 6 goes to 7, 7 goes to 2, or you can go the other way around. But you can't do much more. All right? It's also a valid US phone number. How about that? Hopefully that person doesn't get annoyed by the fact that they have this amazing phone number. Like imagine you had that phone number and there was somebody who just liked to press the Knight's Tour on keypad. That would be annoying. Okay? But by the way, this is not the only answer. I also can take the whole thing and reverse the entire thing, right? So I've got these two options. So there's two more options. Or reverse. And that's it. So there are four different answers here. No, please don't all call them. That's not polite. But if you take these two and then you reverse them, then you get 2 + 2 is 4. I did not expect that to have a nice answer. I thought this was going to have a big mess of an answer, because usually the problem of find all the different routes to go through something is like you write a computer program and it finds all kinds of different things and no systematic way to get the formula. But this has a nice answer. Thank you very much for sharing this question. I'm impressed. All right. We have a few minutes left. Let's use a few minutes left to go and talk about some lighter questions. I see. Some people have said this has a name, So Skylar Shreya says this has a name. It's called the Knight's Tour. Right, because it's like a knight taking a tour. That's all it is. Unfortunately, in this particular Knight's Tour, the knight doesn't get back home. The knight ends up stranded, starts at 5 and ends up at some mysterious place like 8. And as you know, knights are they're just like incapable of walking just like that way to get home. Knights can only jump. Yeah, very realistic. But anyway, they are called Knight's Tour. Okay. Great, and actually Keshav said this is also called a Hamiltonian path in a graph. That's also true. That's what we are trying to do here. Diane Hassan has asked, which type of problems do you choose to solve in this stream? I don't really know. What I mean is that I have a team of moderators who helps me to choose some questions from the main stream into here, and I choose the ones that I think just make me want to know the answer. Like I look at it and I'll say, oh, I'm just really curious what the answer is. This could be dangerous because I'm just curious and I might get into the wrong direction. But, that's how I go. And I think that our moderators are often trying to pick questions from the chat, which look like they might be interesting. All right. Somebody else has asked, maybe let's close with this. It's Lakshmi Priyanka. Do you have any tips for math counts? Yes, my biggest tip is, if you like what you're seeing here, keep doing questions which are kind of intriguing. Use exactly what you saw me do, which is to say, ooh, I wonder what the solution is to that. This could be dangerous. Maybe I'll get stuck. But that'll be the fun of it. Let's go and try, because we don't know how to do it. And that particular attitude, when you go in and try to say, let's go and get lost on these tricky looking questions, that's how you get good at math counts. And then whenever you go and see like a real legit problem inside a math counts contest, you hopefully will also have this response of being like, I want to know the answer. Let me try to figure it out. Yes. So, okay. What else can we do? Let's see if we can hit something really, really quick at the end. Oh, okay. Right. Let's just finish this one here, right? It's let me see. Yeah, let me hit this one. So Maz Ahmad, would you differentiate between the range and the codomain of a function? So this is a mathematical technical terminology, and in fact I might even have it wrong. I might even have it wrong because I just think of the meanings as opposed to like having particular words that I associate with those meanings. My understanding is that the range of oh yeah, you guys can all correct me now because you're learning this in school. My understanding is that the range of a function is like how much it can go to. For example, if my function is y equals x squared, then the range is going to be all of the x's which are bigger or equal to 0. The range is literally what you could get if you stuffed something in. My understanding is the range of a function is you stick something in and see what you get. And it's the set of all the things you can get. But a codomain is sometimes used to say, well, actually, you said that this is a function that goes from real numbers to real numbers. And I don't actually remember. Sometimes codomain will mean the same thing as the range. Sometimes people will say, well, you said that it's going to spit out a real number, so let's use real number for that. I'm not really an expert in these kinds of terminologies, so I won't give you a better answer than that, other than, my main question is, what's it useful for? And I always go and think, what kind of problem could I solve with this terminology? I'll introduce terminology if I want to explain how to do a problem. But I won't necessarily dwell on terminology just to be like, that's what that word means and that's the most important thing in the world. With that, unfortunately, that also takes this live stream over time. So again, there will not be a session tomorrow because I will unfortunately be doing something else online. But I'll be back on Wednesday, same time, 4 o'clock p.m. So I'll see you all there. Take care. Bye-bye.